Welcome to a lesson with Dr. Pell. Let's take a look at an example of a parabola written in standard focus form. Let's do this one, x squared minus 4x plus 3. Now, this doesn't look like 8y equals x squared like we were seeing before. The only thing that's really changed is we've done some shifting. If we complete the square, we can see that. In fact, all stretching in either direction is actually already swallowed up in this number. So anything that's extra, if we have any x's out here that are extra, it just kind of goes right into the shifting. So really, P will be the same, since P just shouldn't change if we just shifted our picture around, only if we stretch or expand, but that's swallowed up in here. So no matter what, P is going to be equal to just 1/4 of that guy, which is just 2, which is kind of nice. Then we just complete the square right here. In completing the square, it's kind of nice because at this point, this coefficient right here is a 1. So we can utilize that. We don't need the brackets because of that. Then we just make a replacement here as x minus 2. Quantity square just took 1/2 that -4, made it a -2. And then in making this replacement, we had to see this, take this -2 and square it. It's 4. We added 4. So then we have to subtract 4. And then, of course, we have the plus 3 out here. So this means we would have x minus 2 quantity squared minus 1 is equal to 8y. All right. So this tells us that now it's unfortunate right here that the standard form of the parabola isn't good for some purposes. It's great for finding the focal diameter and also finding out this p-value, which we use to find the focus. However, it's not that great for finding the center. That's why we need the other standard form of the parabola where where this coefficient is just 1 of the y. So we solve for y. So solve for y now. 1/8 x minus 2 quantity square minus 1/8. Now we can see the center of the parabola, right? X equals 2, and the y value is -1/8. That's the center. Just as we always have done it, right? Get it in the other form to find the center. However, put it in this form to easily see what the p-value is and the focal diameter. So in this particular case, we know this is the center, and we should know where the focus is. Because this parabola opens which way? Well, it opens up, notice, because we have a positive 1/8 right here, right? So it's opening upward, okay? So that means the focus is up here. So it's vertically up from here in the y value, and you're going up 2. So from here, you go up 2 in the y value. So it looks like we're going to have 2, and we go up 2 from -1/8. So 2 plus -1/8 is the y value that we need. And this, if we add fractions, this is like 16/8 minus 1/8. So it's like 15/8. So this right here would actually be equal to the focus. What about the directrix? Well, the directrix is just P down from the center. It's going to be y equals, and then we take this y value here and just subtract 2 from it. Now, 2 is the same as, -8 minus 16/8. So you get -17/8. Is that, if I did that right? Yes, -17/8. So we have the directrix, the equation of the directrix, and we get the focus. Now, we had to find the center. Now the center really is best found by writing it in the other standard form where we solve for y. Then we can see the coordinates of the center. However, when it's written in standard focus form like this, we just take 1/4 of that guy right there, and we're set to go. Standard form of a focus happens when the coefficient right here of the x part is just a 1. That's the only difference between forms, is just make this coefficient of 1. So if we were in this form, if we wanted to get that, we just multiply everything by 8. And then so this would be a 1. And then we get to that form. Thanks for watching.